Hi all, welcome to part 11 module 5 computer networks. So module 5 is basically about the network layer supporting protocols, right, other than the core protocol, that is IP. So here we will see another major supporting protocol called the internet group management protocol. So the one which is responsible for the creation of the group, membership of the group, and all other things. So for that, let's start our discussion with unicasting versus multicasting, something we already discussed at different points. So the IP protocol can be involved in two types of communication, unicasting and multicasting. And you know there is broadcasting also, which can be thought of as a generalization for the so-called multicasting. But it is different in the sense broadcasting means to everyone, multicasting means a subset of those every. Unicasting is one-to-one communication, right? So unicasting is a communication between one sender and one receiver. So the normal communication that we discussed so far is unicasting, or it's on communication. However, some process sometimes need to send the same message to a large number of receivers. So the receivers are large, where sender is a single one. So this is called a multicasting, that is one to many communication. So multicasting has many applications. For example, multiple stockholders can simultaneously be informed of the changes in stock price, of course, right? So whenever there is any fluctuation for the stock, that could be informed to the stockholders. Means the same information is being informed, right? So you can make use of multicasting. Of course, if there is a plane cancellation, it can be informed to all the travel agents suddenly. So again, a common information being shared to many. So you don't have to send that many unicasting. Instead, you can depend on the concept called the multicasting. So some other applications include, of course, the distance learning, video on demand, like that. The internet group management protocol, IGMP. So that internet is also to be highlighted because it's the expansion is like that. The internet group management protocol, IGMP, is one of the necessary but not sufficient protocols that is involved in multicasting. Yes, anyway, I just taken it from the textbook. Yeah, we will discuss only IGMP because this is what is being mentioned in your syllabus. But there are other protocols also existing for the same purpose. So the concept here is we have to achieve the so-called multicasting in a general network. So along with IP, we can make use of the protocol called internet group management protocol. So that is one of the protocol, in the sense there are many other protocols that do the same process, but we will be seeing internet group management protocol in detail. So IGMP is a companion protocol to the so-called IP protocol. So let's see how this group management is done in IGMP. So for multicasting in internet, we need routers that are able to route multicast packets. So this is not a general router. So to deal with the multicasting, the router should be capable of handling it. So there we have to do something more in the routing part. So we already discussed the distance vector routing or the link state routing. They are mainly unicasting concepts only. So they will handle unicast messages. But for multicasting, the routers has to be updated accordingly, right? So we should make them in such a way that, so we have to add something more into the routing algorithm so that they can handle the multicasting messages even. Routing tables of these routers must be updated by using one of the multicast routing protocol. So that is a different topic actually. So what we are covering here is IGMP. So you have to understand one thing, it is not at all a multicast routing protocol. So they are something different. But what this IGMP is doing, it is a protocol that manages the group membership. So IGMP is only concerned about the creation of the group, in the sense how a new member can be added in the group, how someone can leave the group, right, and monitoring of the group. All those things were done by IGMP, and also IGMP will inform the so-called routers about the presence of this group in this particular network. These are all the groups or these are all the host who want to participate in this and this group. Like that, it will be informing the multicast routers. But how this multicast routing is done, so that is a different topic again. In our third module, when we discussed routing algorithm, we covered up to unicasting, algorithm which can handle unicasting. But there are, if you go through that unbound textbook, there are separate topic for how this routing is done for dealing with the multicasting. Multicast routing is something differently handled, and also hierarchical routing. Many such topics were discussed. If you have time, you can go through it and you can understand it. But anyway, I'm just going with the syllabus. So as far as the syllabus is concerned, we are supposed to learn IGMP protocol only, which is a group management protocol. So it's a that manages the group membership, that's all. So that will help the routing, particularly the multicast routing, to do their routing process. But how it is done, that is a different topic here. But we will see something, we will get an idea about it once we finish IGMB. So somewhat I will try to give you an idea, but for more details you can read that multicast routing separately. Now in any network, there are one or more multicast routers that distribute the multicast packets to host or other routers. We will see that. You can make use of a single multicast routers or more than one. IGMP protocol gives the multicast routers the information about the membership status of the hosts that are connected to the network. So given any network, who are all the hosts they wish to participate in a particular group or not. So those membership informations will be communicated by IGMP protocol with the multicast routers. Now a multicast router may receive thousands of multicast packets for different groups, right? So in the network, given a multicast router, he will be receiving a number of packets for a number of different multicast group. But whether all those multicast group exist in that particular network where that router is connected or not is a question. If it is not knowing it, what it will do, it will simply broadcast all those packets into the network. If the router is not maintaining some kind of list about all those groups which are part of that particular network, it will simply forward all those packets into that particular network. So that will create a lot of traffic. So what this router can do is, a better solution is to keep a list of groups in the network for which there is at least one loyal member. So if there is there should be at least one member, right, one active member. If that is not the case, then what is the meaning of maintaining such a group in that network? You can simply delete that group information from your list. So always maintain a list and make it up to date in such a way that the list contains all the groups which are having at least one loyal member, right? So such a list will be maintained by all the multicast routers. Now the so-called IGMP protocol helps the multicast routers to create and update this list. IGMP gone through different versions, and we will see the different types of messages. So as per the latest version, that is IGMP version 2. So if you look at the messages, the IGMP Internet Group Management Protocol messages, you can see that there is something called a general query, and there is a special query, there is membership report, and there is leave report. So mainly 4 types of messages we will see. We will see of course these things in detail. And this, for the time being, you can understand it like this. Membership report is something by which a particular process or a host show it interest to join a particular group. If I want to join a group, it will be generating a membership report containing that group ID and also its information. I want to be part of this group, like that. So it's typically generated in 2 contexts. Sometimes inside, so if you look at a host, there will be number of processes running inside, right? And a particular group, say group 1, I'm just saying the group will be having some address and all that we will see. Suppose only this particular process 1 want to join this group and others don't want to join the group. So these processes are supposed to inform its membership report to the host, right? So this is a host. So accordingly, the host will maintain some kind of list. What are all the groups active and who are all the process which are part of this group. Maybe this group 1, this process 1 and process 2, both of them may be part of group 1 or only process 1. So like that, the host will maintain a list. And also when you look at so this particular process 3 may be part of group 2, something like this. So when you look at the router, right, on the way, the router will also maintain a list of all the groups, like group 1 is there, right, and group 2 is there. Because this particular host is part of the network where the router is connected. So who are all the groups this host participated? Group 1 and group 2. Maybe a different host may be part of group 2 again, right? It may be part of group 3. So all those things will be updated in the router. So everything will be done with the help of the IGMP protocol. Now suddenly this particular host, first level, the process don't want, for example P3 don't want to continue in this group 2, right? So that P3 will be informed to host, and this host will inform that to router. So for that purpose we are having the message called a leave report, right? So I want to leave from this particular group. So as soon as a router is getting a leave report for this so called group 2, what the router will do, so simply removing this group 2 from the list of groups maintained by router is meaningless, because the same group 2 some other host may be part of it. So the router have to ensure whether this is something a collective opinion or it is opinion from host 1 alone. So now this host 2 is still part of group 2, right? So it's router can't remove this group 2. So for that purpose router will be sending something called a special query to everyone, so that if someone is still interested to this particular group 2, they can communicate back. So of course host 2 will be communicating its interest to continue with the group, of course using that membership report. So as soon as such a request is coming from host 2, the group 2 will not be removed from router particular router's list. Hope it is clear, right? So that is a way. Maybe my writing and all, even after writing something I am confused on what I wrote. So that is the thing. Anyway, we will see these messages in detail in our subsequent discussion. So general query is something, this is a monitoring purpose. Special query is generated when there is a purpose, so just to make sure that this group is still active in any of the hosts in my network. Is there is at least one loyal member in the group or not. So like that a router can ensure by sending special query. But what about general query? There are situations like a particular group, there may be only one active member, maybe only one host. For a particular period of time that host gone offline, or it is having some problem with it. So what will happen? Actually there is no loyal member in the group at all, but as a host gone offline, it is not in a position to send a leave report and all. So the router may not understand whether some of the groups are active that particular time or not, if in between the members of the group has some trouble or not. So those things the router is not updated, right? If they are active, they want to leave, they will send a leave report. If they are not active, they may not be in a position to send leave report. Now the router is supposed to monitor the status of the network. So that is where it is sending a general query, maybe with some in a periodic manner, and it will ensure whether all these groups were active or not. So whenever such general query is coming, the individual hosts are supposed to send the membership report. So by looking at the membership report, the router can understand that yeah, this host is interested on this and all this and these groups, and this another group host is interested on these and these groups, and accordingly it will keep its list. But if no response is coming for a particular group ID, it can simply remove that group ID, because there is no active member of that group in that particular network. So that is the purpose of general query. So hope it is clear, right? So anyway, we will see them in detail. Now let's see the general format of a typical IGMP message. Again, before discussing the message types and all, we are moving on to the format. So you may be having some doubt. Further, it will be cleared when we discuss the message types. So if you look at the header format, there is a type information, of course, an 8-bit field, a maximum response time, another 8-bit field, a checksum field, 8 plus 8, 16-bit field, right? So it's a 16-bit field. And of course, a group address in membership and leave report and special query, and this will be all zeros in a general query. So, and that for us in textbook some printing mistakes were there like this, all zeros, right, in general query. So we will see that. So type, in the sense we already seen 4 different types of messages. So this will be a field that indicates what type of message, whether it is a query message. For general and special query, a common type is used, or whether it is a leave report or whether it is a membership report. So that will be indicated by the type fields in 8-bit field. Maximum response time is particularly for the query message. So whenever you generated a query, after how long the machines are supposed to respond back with the query. So that is maximum response time. It is something represented in the unit of 1/10 of a second. So that is something you can keep in mind. I don't know what is the reason, but anyway they are representing like that. Checksum, just like we already seen in IP or in other protocols. So 16-bit checksum, you know how to generate the total message. So it's generated for the entire ICMB message, that is of, the first row is of 8 bits is 1 byte, right? So 1 plus 1 plus 1, 4 byte. And the second row is again 4 bytes. So totally for this 8 byte, why this address is again 32-bit IP address they are using. So that is why it is coming like this. So for this 8 byte, this checksum is being generated. Those 8 bit will be divided into 16, 16, 16 bits, and we will add and we will generate this 2's complement. So that procedure, the same thing we saw in IP will be used here. And at the receiver side also we will add everything with this checksum. If the result is 0 means the 2's complement is actually the negative of the sum, right? So when you append this 2's complement at the checksum field and at the receiver side everything is added again, so all others will give a sum and this checksum will be its negative. So together it will give 0, there is no error. Otherwise there will be error. So that is the way the checksum is calculated. The same procedure we discussed in IP and all. So group address, the group ID, actually that multicast group address is mentioned here, and this multicast group address is actually needed for the membership message, because a host want to be part of this particular group, so group ID is to be mentioned. Also someone want to leave this particular group, so group ID is to be mentioned. So special query again for this group, if anyone is interested or not, like that the special query is generated. So again that group ID is to be mentioned. But if you look at the general query, so that is not for a specific group, it is something general to everyone in the network. If just the router want to update its table, whether all the groups in the maintained in the list at the router is active or not, so that is the purpose where that general query is being generated. So whenever general query is coming, every host is supposed to report that membership report with all the active groups. So that is a requirement. So you can't pinpoint to a particular address, right? So that is why this field is kept as fully 0 in case of general query, right? So type field, so something I explained already, just mention here. The 8-bit field defines the type of the message as shown in the table below. Just like if it is a general or a special query, it will be some hexadecimal value. 1 equivalent binary is also given. So hexadecimal 16 for membership report and hexadecimal 17 for leave report. So this is how the messages different types were identified. So these 3 are major, but why the 8-bit field? Future and more types may become, right? So accordingly to deal with that, they were providing 8 bits for the type field. So maximum response time checksum, and so maximum response time is an 8-bit field. It defines the amount of time in which a query must be answered. So that is particularly for query messages, not for the other membership or the leave report. And its value is represented in tenths of a second. So I couldn't understand why this unit is taken like that, but maybe for some reason will be there, but from the textbook I couldn't understand. But they were representing like that, the tenths of a second. For example, if the value is like 100, the actual value is 10 second, right? So here the unit is 1/10 of a second. So that is why it is multiplied by 10. I hope you get the meaning, right? So the value is non-zero in any query message. For query message, we are supposed to give a particular timeout. I mean, some value there, and within once that value expires, we are supposed to get the response back. Otherwise, we will assume no one is interested, something like that. So for query message, it will be having some upper limit, some value will be there, but the other 2 types, that is whether it is a membership message or a leave report, that maximum response time is not needed at all. So this will be set to 0. Now what about the checksum field? It's a checksum field, it's a 16-bit field, as we already said. Checksum is calculated over the 8-byte message, like what we see. So group address, this field is the multicast group ID. So for general query, it's not pinpoint to a particular group, it is general to everyone in the host, right? And for applicable to all groups, so it will be all zeros. But if you look at the special query or the membership report or leave report, that particular group ID specifically has to be mentioned there. So there we have the 32 bits for representing it, the corresponding IP. For multicasting purpose, we have a class D, right? Something we discussed already. So class D IP address will be used in multicasting. What is the range for class D? Even I too not remember. So something like 0 to 127. I hope it's class A. 128 to what is that, 191, it is class B. Then 192 to 223 it is class C, and 224 to, right, now I remember, the 239 is class D, right, and finally the 240 to 255 it's class C. So this is something reserved for future use, right. So this is the multicast, the one which is used for the multicast purpose. So this is the last octet only, so completely it will be what is that, 224.0.0.02 239.255 all those things we discussed already when we in our IP classes. So go through those sessions for clarity if you still have a doubt. So this is a range of address that is being used for the multicasting purpose if you look at IP version 4, and those 32 bits will be stored in the group address, particularly for the membership, leave report and special query, and for general query it will be all zeros, right. Yeah, thanks for watching, and subsequent video we will see more details.